Hello, everyone. Welcome to our very first AirWeights live stream. Thank you so much for being here. And I just wanted to acknowledge you all for showing up. Thanks for being here. Like I said, if for some reason you joined this stream from another channel besides YouTube, I highly recommend that you come over to YouTube. And it'll be a better experience on this side overall. So if you're on Instagram or Facebook or something else, please make your way over. Tonight we're going to do quite a few things, so a lot to cover, and really excited about what we have to show you. First things first, I'm going to bring out Kate. Kate's our operations manager, and she's going to be in the background tagging questions and getting ready for our live Q&A later in the show. And she's also going to run our giveaway. So thank you, Kate, for being here, and grateful to have the support. So the show is going to go basically like this. We'll go through a little bit of my background, tell a bit of a story of how I got into this, and why it's relevant to you, and some of the pain points that I experienced and how I got through those and sort of developed AirWeights as a business. We'll go through several of our work holding methods, all of our 3 primary methods that we recommend for vacuum work holding, some tips and tricks, and how to solve some of the issues that we commonly see as questions from customers. And then we'll do a live Q&A. So throughout the show, if you have questions about our products and how to use them, or general questions, please post them in the chat. And then Kate will be monitoring the chat, and she'll be tagging questions so that we can then come back to them for the live Q&A and go through all of those. As questions come up, we'll get those tagged and filtered in. And then finally, at the end of the show, we're going to be doing a live giveaway. So at some point in the show, we'll have a hashtag that we'll release to you. You'll enter it, and that'll enter you into the giveaway. We'll be giving away a 24x24 complete system. For anybody that was on the IDC stream that we did recently, it'll be the same system, same giveaway. And if it doesn't fit your machine or it's not quite right for your particular setup, we're happy to work with you for the same value of that system. So without further ado, let's get started. So a little bit about me. For those of you who don't know me, my name is Jace. I'm the founder of AirWeights. And I had an opportunity about 5 years ago now to work in a small manufacturing business. And we were making very exotic parts, really different things, organic shapes. And coming from the mechanical engineering background and working with CNC milling and vices and stuff, I tried all the traditional work holding methods. I tried screwing material down. I tried clamping it in place with toggle clamps. I tried even some tape and glue and things, and nothing worked for us. And I spent a good portion of 6 months trying to come up with a method to make these really complex parts. And eventually we went down the path of vacuum work holding, and it just changed everything. Our run times were faster. We could cut more aggressively. Our parts came out cleaner. We didn't see deflection underneath the component. We didn't see rise in other areas. We had uniform work holding, super tight tolerances, and we were making our vacuum fixtures in place on our CNC. And because of that, we were able to produce completely flawless, beautiful parts. And that's the experience that I want all of our customers to have, to be able to put down a piece of material on their CNC on a dedicated fixture or directly mounted or using tile gasket and MDF, a spoil board, all these variety of methods, and then walk away with a finished product and an experience that's just a joy instead of a frustration. So, no more tabs, no more onion skin, no more tape, no more CA glue, to just have an experience that's more fun and enjoyable. And if you're on the business side, something that's much more efficient, that saves you time and that saves you money. So that's the whole kind of backstory of how I got to developing AirWeights and where it comes from. It comes from my experience running machines and producing parts very efficiently domestically that then could be sold for a profit and saving businesses money. So that's a little bit about my background. The next thing I want to do is just jump into some of the work holding methods that I've got presented behind me right here. We're going to go through a few of the primary methods. So the first method that we'll talk about is direct mount. Direct mount is where you take a workpiece and you put it directly on your vacuum table. And that's our system that we sell. Our complete system comes with everything you need to use the system for direct mount, that direct mount method. There are some limitations. We'll go over that, but that's the first thing we'll talk about. The next thing we'll talk about are fixture plates. Fixture plates are essentially another plate, a layer that you put on top of your vacuum table that is non-porous and allows you to create the same amount of force that you would with direct mounting, but protects your vacuum table if you were to cut through for some reason, whether a bit slips or you want to cut through and leave a completely finished part. Fixture plates are a way to provide that flexibility with a very, very rigid work holding method. The next thing we'll talk about are spoilboards, MDF spoilboards. This is the more traditional approach to vacuum work holding in the CNC router space, where you basically have a piece of MDF that's porous and that allows air to draw through the material to create negative pressure underneath your part. There's some really creative things we can do with gasket materials and spoilboards to create really rigid work holding. And I'll also demonstrate the advantages of using those gasket materials so that you can make smaller and smaller parts without losing them, having them slide, etc. So those are kind of the three main categories that we're going to talk about: direct mount, fixture plates, and MDF spoilboards. So I'll show you a few of the demos I have set up right behind me. And again, we're going to start with our direct mount. And I'm actually going to bring the camera a little closer just to show you a close-up of this setup, so you can get an idea of what I have set up and what I'm talking about and the proper way to do this. So I have a piece of example stock right here. I think it's about 8 by 10. And I have a setup on this vacuum table, which I have as an individually addressable zone. So looking at this, you can see that we have some gasket material that's surrounding one of our vacuum ports. So this is where air is going to be sucked through the table. Every single one of our other ports is plugged. These come with your system. One of the most common issues we see is people forget this corner port, so don't forget that. But the only air path that we have available right now is this hole. And then all of that region is sealed off with gasket material. I also have some little hard stops. These are a little 3D printed part. We've demoed these in the past. We're about to release them as a product, but for right now, they're just prototype. I've mentioned this in other streams, but if you have a 3D printer and you're interested in these, then I'm happy to send you the file for those. So essentially, this piece of material can butt up to these repeat stops. I have a sealed zone underneath here. And if I turn on the vacuum pump, it'll suck down the material flush to the vacuum table. The gasket will compress into the channels, and the material will contact the vacuum table. So I'm going to go ahead and turn on our vacuum pump. I'm just going to set this down, give you a little bit more space, and turn on our pump. And I'll change our valves here. So now this piece is rigidly held. I just adjusted my manifold over here to activate this vacuum table, and now this thing is like impossible to get off. It's super rigidly held. I can shake the CNC before I can move it. And because I have stops set up, I can push the part back into that same position repeatedly. So if I had something like an engraving project, a customization for Etsy, it's a very simple way to repeat locate with these little tabs. And even if you didn't have that, you can sort of use the grid pattern as an alignment feature to get back to a very similar position. So I'll go ahead and shut off the pump now. And I can release pressure, and the part comes right off. So that's a methodology that a lot of people know about. We do have a video on this. And it's a very quick and effective way to do projects without doing a lot of custom fixture work. So that's our first methodology, is direct mount. The stops are a really great new feature and add-on that we will be offering very soon. And like I said, if you have a 3D printer, it's a great thing to print yourself and then just integrate with your system. Hard stops, I do see a question about when we can order hard stops. Those little locator accessories, I expect, if you're really wanting them, John, let me know, and we can print some here and send them to you. If you're willing to wait a little bit, we'll have another version that's a machined part that'll be available probably in about 2 months from now. So prototype versions are available. If you have a 3D printer, totally available. I'll give you the file. And if not, it'll be about 2 months. I'm going to move on to the next method, and that method is fixture plates. So fixture plates are a piece of non-porous material that sits on top of your vacuum table. And I have one set up right here. And again, I'll pick up the camera and just show you up close what we've got. But essentially, it is a piece of non-porous material. It has locating holes in the corners, all 4 corners. And that allows you to repeat locate the fixture relative to your AirWeight each time you replace it. So if you take this off and put it back on, you can have the same program run in the same position over and over again. So for repeat production parts, there is not a better solution. This really pays for the design time it takes to just set it up. If I get a little bit closer, you can see I have the perimeter of my part right here that's been machined. I'm cutting all the way through, and I have a vacuum port in the center and gasket that goes around the edge. And essentially, we're creating a vacuum pocket in here. And since the gasket is sitting proud of the surface, there's a thin air gap all around in here that gets evacuated. And so long as your material is thick enough, then it should hold just fine. If you have a thinner material, sometimes it can tend to deflect in this region. And there's a better way to hold thinner parts that have, where you basically recess the gasket into a channel. So I'm going to pull this back again. And I do actually have a demo of this that I'd like to run. So I'm going to take that same piece of material that we had set up for our direct mount method, and I'm going to place it on this fixture plate. The finished part just has a profile cut in it and a little pocket on the top side. And to align it, since I have a cut already in the fixture plate, all I need to do is make sure I'm overlapping into that profile cut everywhere. And I know I'll get a finished clean part with no tabs and no onion skin. So I'm going to take this piece of material and I'm going to place it right on here. And I'm just checking to see that I'm overlapping my gasket material everywhere. And then I think somebody was asking about how to have multiple vacuum tables on the same setup. We use a manifold for that. And we have some manifolds we use internally here that are not as nice as what we sell, but these are the manifolds that we sell. So get a little closer up here. It's essentially a 1/2-inch input, and then you have all these ball valves that have a push to connect that goes out to each vacuum table. This is a 5-port manifold. It works pretty well for a 4-position vacuum table setup because you can use one of these for an auxiliary gauge that you put next to your controller or somewhere that's visible rather than just keeping one down on your vacuum pump. It also has a release valve so that you can release pressure to let go of the parts that you're holding. Once you turn off the pump, sometimes there's residual pressure inside the system that you need to purge, to allow it to equalize. So this is our solution for how you get to multiple tables that are all connected, and it's a nice feature to have them be individually addressable. So back to this, I'm going to, using my manifold down here, which you can't really see. Now you can see it. I'm going to shut off the valve that goes to this table, and I'm going to turn on the valve that goes to this table. And then I will turn on my vacuum pump again. And anytime that you're using vacuum work holding, you always want to check that the part is rigidly held before you machine anything, ever. So I can tell just by the sound of the pump, I can tell by the gauges that I have here that I'm pulling deep vacuum. You can also tell because this thing is rigidly on here, and I can't move it at all. So something that we haven't done yet in any of our streams is to cut something live. So we're going to do that now. And to save your ears, I'm probably going to mute the stream while it cuts. But we'll show a live cut where we cut a little pocket and a profile, leaving a finished part. And before the stream, I zeroed everything and got it ready, so it should be good to run. So give me a second to set that up really quickly. One sec. Oh, Kate got me. Okay. So that was a completed part on a fixture plate. I still have the vacuum pump running. I'll go ahead and shut that off. And I can release pressure using the release valve on my manifold, and then I can take the part right off, and it is finished. So No tabs, no onion skin, perfectly clean edge, little AirWeights logo. And that's the capability that you gain with setting up a fixture plate. Now that I have this set up, I can just load another piece and press go again and just pump out the same thing over and over again. So for the business owner, for the person who's launching a company, for somebody who wants to make product in volume, this process is extremely valuable. It's very, very, very valuable. And we're working to try to make this process as accessible as possible using a variety of different approaches that get you to the same position. So in other words, we have a variety. All of our gasket materials come from All-Star CNC products. We love working with those guys. They're a partner of ours. They make incredible stuff, and they've been serving the CNC routing community for a long time in more of the industrial space, cabinet shops, door makers, that sort of thing. And they've worked with us. We've developed some new products, one of which is these new gasket squares that we have. So these you can pick a size that works for your particular part size, stick this right onto a fixture plate, and pop a hole in the center, and you have a vacuum clamping surface within that region. One of the things that I think is really important to mention about fixture plates is you are relying on it being an airtight system. What that means is if you were to cut through somewhere inside the region of the gasket, you need to account for that with gasket material. So let's say, for example, on this part that I had a hole in the corner right here. I would need to have my perimeter gasket, and then I'd need to have a hole with I need to have a circle of gasket that accounts for the fact that I'm going to cut through right in that region, so that when I cut through, I don't breach the seal. So for anything that has an internal through hole, you just need to account for that with gasket, and you get the same result as you would with this part right here. Most commonly, people making projects with a CNC just want to be able to profile the part all the way out, but there are instances where there are through holes. People who make all sorts of different parts, MFD displays for boats and things like that. So you have a methodology for doing that, and again, really, really repeatable process. A couple other tips for fixture plates that I want to mention. If you are going to need extremely tight control of your Z heights, where you're doing something like an engraving and the depth of the engraving is really important, I highly recommend that you face your fixture plate under vacuum before you put any holes in it, so that you get a perfect Z reference relative to your machine and your installation, and that can save you a ton of headache down the road or needing to remake a fixture. The other thing about fixture plates is you can nest multiple parts. So like I have one part set up on this, but if I was running production and I wanted to make these parts, this example product that I just made, which was like a, 5-minute program, I could have essentially, 3 or 9 or whatever, however many I can fit on one fixture plate on there. And then I can have longer run times and be doing other things while the CNC is running to optimize my throughput. So solving lots of problems with this solution. And again, we're doing everything we can to make it as accessible as possible. One of the ways that we're doing that is by offering a pre-cut fixture plate. So this is essentially a replica of the grid in our vacuum table, less the mounting holes around the edge. So it gives you the full grid pattern. And you can take this, which comes with no holes in it, just locations that match with the ports underneath. It's totally solid on the backside. And you can place this on your vacuum table, face it, and you have a perfect Z reference. And then the same way you lay gasket into the grid for direct mounting, you can use this setup to create custom fixtures with a lot less work for you, where you suck your part directly down to a stable Z reference. So this is a really cool new thing that we're offering that provides a lot of flexibility and takes a lot of the customization out of making fixture plates. The main difference between this and the fixture plate that I have set up here is that this gives you a stable Z reference that you're pulling the part down to, whereas this fixture plate, the material is floating on a gasket. For a lot of stuff, that's totally fine. But if you're doing extremely tight tolerance work, you want to pull the part down into a surface that you've machined with your CNC. And then you can get, I mean, really, really tight resolution on your parts. So that's fixture plates for the most part. There's a variety of gasket options with them. You can use an onboard gasket, which is what I used in the demo, where you just stick it on top and put it right inside the profile of your part, pop a hole in the center. You can also use these gasket squares that I discussed, where you don't have to do anything with a strip of gasket. You just stick this on, which we'll demo on the MDF spoil board as well. The other thing that you can use is something called cover gasket. And cover gasket is a sheet of gasket material that's completely solid. And you can stick this onto a faced fixture plate and then use an engraving bit to cut the gasket positions of each individual component. So if you were going to nest a ton of small parts on a fixture and you wanted to make them in volume, this is a really great approach because you let your machine do a lot of the gasketing for you and creating those custom zones. But it is more design work up front. So some of the other methods can be a little bit more, depending on the part, it can be quicker to just use our onboard gasket or the gasket squares instead of this. But if you have really tiny stuff like keychains, dominoes, things like that, both things that customers have made, our customers have made, this stuff is great. So the next thing I want to talk about today is MDF spoil boards. So MDF spoil boards are basically MDF is porous, and it allows air to pass through the sheet. So when you turn on a vacuum source underneath a piece of MDF, what you end up having is a very thin layer of negative pressure differential right at the surface of the MDF, where the MDF is coming into contact with atmosphere. So what happens is if your part is really smooth and it's really stable and it's really consistent and flat, then you can get pretty good work holding on just a pure piece of MDF. The moment that you have any sort of surface irregularity, you have grain direction that's significant, it's kind of coarse, or you have warp or bow in the sheet, it's hard to get the MDF to hold the component down because the two faces aren't in perfect contact anymore. You're kind of floating on the surface of the MDF. And so having another material between to help account for some of those surface irregularity matters a lot. The other issue is that basically all of the air on the surface of the MDF is escaping. Any part of the MDF that's exposed is contributing to vacuum loss, meaning that if you have exposed MDF and like on this piece behind me where it's basically just a whole exposed piece, all this exposed area is wasted vacuum, so to speak. It's not contributing to work holding at all. It's just it's being dispersed to atmosphere. So when you put a gasket on top of MDF, you don't need to drill a hole in the same way that you need to do with a fixture plate because it's porous, it'll just leak through. But the gasket contains pressure between the part and the spoil board and creates a little custom vacuum pocket right there. So that's another really quick and easy way to to set up a part that you want to cut all the way out, is to just use a gasket square on MDF. And that's exactly what this is. This is one of our MDF spoil boards that just has one of those gasket squares stuck right onto it. And so when I turn on the vacuum pump for this particular spoil board, there'll be a little vacuum pocket right here that's doesn't produce as much work holding potential as a fixture plate because we're leaking everywhere. And then all this, like I said, is going to be leaking. So let's just demo that really quick so you can see. Sorry, give me 1 second. I got a little chips I got to clear off here. Kate, will you mute my mic really quick? We're going to stick this back on, and you can locate these with pins. I'm just, for the purposes of demonstration, I'm just putting it on there. And then I'm going to adjust my manifold again. So I'm going to turn off this front right position, and I'm going to turn on the back left. And I'll turn on the vacuum pump and then just take this example part that we have right here and drop it onto that gasket zone. So turn this on. And I'm going to give a little bit of a push on here to seat the seal. And it sounds like maybe I have my release valve open. I do, so I'm going to close that. You can hear the sound of the pump change. And then I'll take this example part that we made, and you can see that if I put it on just the MDF, it holds a little bit, but it does tend to want to slide. Whereas if I put it onto this gasket and I'm covering the entire thing and give it a second to equalize, apply a little pressure, now that thing is on there, and I can cut through all the way around the edge into the MDF as a sacrificial surface and still maintain work holding, so long as I don't cut through within that gasket region that we talked about. So the work holding is very rigid. Again, I can shake the whole machine before I can move this thing, and I can turn off the pump and release pressure with the valve, and then this thing comes right off. So that's a very quick and effective way to set up a part if it's smaller in size. If you're running stuff that's 2 foot by 2 foot, 1 foot by 2 foot, and you have all this area to work with, then having a gasket may or may not be required, especially if your material is super consistent, something like melamine or sheets of plastic. We have customers that use bare spoilboards and cover it with EVA foam and use a drag knife to cut out certain shapes. So there's ways to account for leaks with MDF, but for the most part with our systems, we do recommend using some form of gasket material with an MDF spoilboard to help improve your work holding. So that leads me to our final method that I want to discuss today, and that's tile gasket. Tile gasket is a perforated foam rubber sold by All-Star. We sell them also as pre-applied pieces so that you don't have to do this stuff if you don't want to. But essentially, what this does is it seals off all of the bulk surface area of your MDF spoilboard. The only areas that are exposed to atmosphere are the edges and anywhere that's outside the seal on the bottom side. So to optimize the performance of one of these assemblies, you would want to seal the edge and a 1-inch border on the bottom side of this entire border all the way around, so that the seal that's installed in the vacuum table contacts a sealed surface here, and all of the air is being sucked through these ports on the top side. So that optimizes the performance of this. If I'm being straight with you, the performance gain is not significant because the surface area of this relative to an entire surface of a spoilboard is not significant, especially with some of the sources that we have now, like our new 17 CFM pump. So this does two things. It focuses vacuum to these little tiny holes, making each one of these act like a vacuum pocket, like a vacuum clamp. And because you have so many spread out contacting the surface of your part, it can produce extremely rigid work holding. The other thing that this does is it increases the friction between your workpiece and the spoilboard because you have a gasket in between. And the friction between rubber and wood is a lot higher than rubber or than wood and wood. So I'll just do a quick demo of that. The way that you use this, though, is you put your workpiece down and you turn it on. And in any of our methods, ever, if you're at any time you're setting your Z height, always make sure you're doing it under vacuum with the part rigidly held, because the Z height will fluctuate based on whether it's under vacuum or not. So make sure you turn on the vacuum pump before you set your Z0. Just want to make that clear. I've made that mistake in the past. I don't want any of you to make that mistake. So just a quick demo of this. You basically cut all the way through and it becomes like a universal work holding surface where you can put the part anywhere and it holds it down rigidly. The key here is that you want to preserve the service life of this material. So ideally, you would put your spoil board down, face it, and you can face both sides, and then you stick the tile gasket on and maintain the orientation of the MDF spoil board so that you know that it's essentially perfectly trammed to your machine. Then when you put your part on and suck it down, you can cut through by a very, very thin amount, a very small amount, and just skim the surface of this material while still getting a complete through cut. And that preserves the service life of this material. And a lot of people who have really, really well-calibrated machines are able to get 250, 300, 400 hours of service life out of one set of tiles. In the hobby space, that's a lot harder to do because the calibration of prosumer style machines is not quite to the standard of some of the larger industrial systems. But if you can cut through by 5 thou and kind of keep your through cuts to a minimum, you can really get a lot of service out of one piece. So let's put this on here. And I'm going to adjust my manifold again. So I'm going to take that back left and shut it off. And I'm going to take my back right and turn it on. I'll turn on the pump. And I have my release open again, making this mistake over and over. So I'm going to close that. And if I put my hand on this right now, I can feel air being pulled through these little ports and sucking on my hand. And if I take our example part, which again is an 8x10 piece, I put it in the center, I give it some time and push down, it's on there also. So again, shaking the machine, trying to get it off, not happening. One thing about tile gasket that's unique is you can burp the seal a little bit easier. I don't know if I can do it with this one, but sometimes if you can get a corner, you can actually get it off, there you go, without needing to turn off the pump. But if you're pushing laterally side to side, it's extremely rigid work holding. So that's kind of a unique feature. Similar if you're using a spoil board by itself. I'll shut that off. And pressure equalizes really quickly because there's some leaks. And this comes right off. So that's tile gasket. A couple of things I want to mention about tile gasket. It's not for every material. Okay, so first thing is if your material is flat, non-porous, consistent, smooth, works great. So like as an example, let's turn that on again. And I'm going to grab a piece of Bamex. So Bamex is a material from CIC Workshop, and this material is really nice. It's smooth, flat, non-porous. I mean, it's about as good as you get with a wood panel. And again, this is 2 feet by 2 feet. It covers the entire surface of the vacuum table, so it's really nice from a leak perspective. You're not getting a lot of leaks at all. If I put this on here, give it a second, I can already hear the pump changing tone, meaning that it's essentially drawing very deep vacuum. And now there's nothing I could ever do to get that off. So yeah, we're pulling like 25 inches with that thing fully covered because we have so few leaks. We're covering the entire surface of the tile gasket. So tile gasket is extremely good for processing non-porous sheet goods. If you're cutting melamine all day, if you're processing Bamex or some of these other pre-glued panels that you can get from CIC Workshop or any sort of sheet good plastics, it works amazing. We even see people cutting dye sublimation blanks from thin aluminum stock on tile gasket. So that's when it really shines. And when you want to cut something that's a more traditional wood, if you can plane it really flat and cover up the entire surface of the tile gasket, it can work really well. But I just want to make sure that people understand that the consistency of the surface, the flatness, how smooth it is, really matters for the amount of work holding you can get on tile gasket in particular. So that brings us to sort of the sort of culmination of all of our methods. We talked about direct mounting and vacuum chucking components directly to the vacuum table. We talked about using a fixture plate and the production capability you have with that, as well as a variety of different gasket options. We talked about bare spoilboards and improving work holding on smaller parts using some form of gasket directly on the MDF. And then we talked about tile gasket, which is a universal approach that improves the work holding dramatically for sheet goods specifically, especially non-porous, flat, smooth sheet goods. So that's kind of all the demos that I wanted to go through, and I think it's a good time to transition to our Q&A. I've seen a lot of questions come through, so we're going to jump right into the Q&A here. So Harry, thanks for being here, Harry. How to hold small aluminum objects such as credit card blank sizes? Great question. So the number one thing about vacuum work holding that most people, or some people don't understand, is that area is everything. So for a given vacuum pump and a given setup, you're going to have some fixed pressure difference that you can ultimately get to. So the amount of force that you get pushing down on that component is just the pressure difference, which for our systems is like a round number. It's a little bit more than this, but about 10 pounds per square inch is what you can expect to get with our source in a fully sealed system pulling on a specific component, right? So if you have something that's 10 by 10, for example, you can get 10 by 10 is 10 times 10 is 100 square inches, and if you take 100 square inches and multiply it by 10 pounds per square inch, you can get 1,000 pounds of downforce. So the resistance to that part sliding around is basically the coefficient of friction times that 1,000 pounds to keep it from moving, keep it from sliding. And so when you have really small parts, the way you have to approach it is, how do I maximize the pressure difference that I'm getting on that component? And that means basically two things: optimizing the amount of area that you have underneath that part that's under vacuum, and then also increasing the friction coefficient, if you can, between the workpiece and whatever it's sitting on. So the most success that we've seen with small, intricate parts the size of credit cards, dominoes, keychains, that sort of thing, is using that cover gasket material I showed earlier. So that would be this stuff, and you could take a fixture plate, face it, get it totally flat and coplanar with your particular CNC with the AirWeight installer. You're accounting for any error in the installation, and then you stick this on there. And once you have it stuck down and you apply pressure to set the adhesive, you come in with an engraving bit and you engrave away all of the material you don't want anymore, leaving just continuous gaskets for those individual positions. Then you come back and mark the positions for through holes, where you're going to create a hole that connects that little vacuum pocket you just made down to the grid underneath and eventually the vacuum pump. And that creates a little individual vacuum pocket for that individual component that you can then suck down your stock and come back and cut all the way around. There are some techniques or approaches that are common when you're making small parts, or that can be advantageous. So I was talking to somebody the other day who wanted to make sunglasses, and based on what I just explained, the amount of area you have to work with the sunglass frames is basically next to nothing. You get, very, very, very little amount of force pushing down on that component. Plus the aspect ratio, especially of the temples, is really challenging to hold, because as you get way out away from the center of the part and you impart force on it out at the edge, it applies a lot of torque or a big moment on the part and wants to kind of fly off. So there's a limit. There's a physical limit, a Newtonian physics limit to what you can do with vacuum. And for really, really, really tiny parts, it's very challenging. But for something like a credit card, you can get there. It just takes some custom work and a little bit of setup time to get to it. But we've seen people make stuff. I cut a 2-inch diameter circle for a customer out of 20 thousandths aluminum, and this is the piece that we used to do that test. So you can see, like, I don't know if you can tell on here, but there's all these circles. And the test was, okay, I think it's 6, 5, 4, 3, 2, 1.5, 1. And we failed at 1.5. So we were able to cut out a 2-inch diameter circle on tile gasket. If you were running production and running a lot of these credit card style sizes, I would highly recommend making a dedicated fixture. But like I was saying, there are some approaches you can take to help improve your work holding process. One of those is leaving a thin onion skin at the very bottom of your cut, and then coming back and cleaning it up in another finish pass with a more conservative approach that wouldn't send the part flying as much as a really aggressive cut. So imparting less force on the part. But yeah, we've seen people make dominoes using cover gasket. So like, 1x2, 3/4 inch by 3-inch keychains, things like that. And I've done it with pretty good success. But that's the approach that I would take, is a cover gasket custom fixture. And do the next question. Okay, so Nature's Live Edge, thanks for being here. I purchased the 17 CFM pump and want to make some specialized fixtures. What material do you use for the vacuum plates? Thanks. The material that we use is a non-porous plastic. All of our materials are part of our competitive advantage, so we don't disclose the exact grade of the material. But I can tell you that for vacuum fixtures, anything that's a non-porous, ideally plastic material, will work really well. Some people have success with some more porous or general materials. You can like seal MDF and use it, but I don't really recommend that. If you can find a non-porous plastic that you can face that won't warp, that's the material to use. That's what I'll say. I know it's not very helpful, but we do offer fixture plates, and they're not that expensive. So hopefully we can support you that way. All right, Greg from STL Woodworking, thanks for being here, man. Can you explain to everyone as far as what MDF to look for if they're not getting it from you? Great question. So not all MDF is created equal. MDF comes in a wide variety of densities, wide variety of qualities, wide variety of surface finish and manufacturing processes, which is all something that I had to really learn the hard way, because when we started out, we were selling tile gasket, and this is before our pre-applied assemblies. We just saw so many people setting up their tile gasket, putting their MDF on, facing both sides, sticking it down, and it just not working at all. And it all came back to the source of the MDF. And so basically what happens is there's an optimum range for the density of the material that will essentially choke the flow of the pump enough to create a pressure difference instead of just breathing so much that there's no pressure difference produced. On a large industrial system, you're producing, hundreds, if not thousands of CFM of flow rate. And that amount of flow can overcome any density issue, big industrial systems typically use ultralight MDF because they're producing so much flow that the pump is going to produce negative pressure through that MDF no matter what, whatever the leak rate is. So with our systems, we prioritize deep vacuum. Our pumps prioritize achieving a really deep vacuum, and most of them achieve, negative 25 inches of mercury. And they're oilless, so it's a unique combination of being able to produce deep vacuum and also pull air without it being an issue. But all that's to say is that our systems really like 48 pound per cubic foot MDF. And that's so that the reduction in flow rate is enough to build up a pressure difference and create that negative pressure on the surface of the MDF. It's also worth mentioning that I'm testing all of these systems with all of these setups with a 17 CFM pump down here. The same general principles apply. And the more flow rate that you can afford to get with one of our systems, the better the performance you'll have, and the more leaks you can account for. So, I always tell people, if you're on the fence about which pump to buy, always, if you can, go bigger. Not because not because I'm trying to make money, but because I want you to have a good experience and be able to have a pump that can meet the demand that you're asking of it. So 48 pound per cubic foot MDF. The stuff that we sell is called Medex. I have no desire to be selling MDF. If you all could go source it yourself, I would be so happy. But we did that out of a need that came up in our community, where not everybody could source a material. The big box store doesn't always carry something that's consistent and reliable. So that's what we started doing, is providing spoilboards just to allow people the flexibility to make parts on their setup the way they want to. Stephen McIntyre, what's up? What method do you recommend for aligning work for two-sided machining when it is a one-time project? I typically have aligned by boring holes in the spoilboard and the workpiece and using pins dowels. Yeah, great question. So I love two-sided machining. I think it's one of the most beneficial things that you can do. The short story is that any of the traditional two-sided op kind of methodologies work on our system as well. You can do that same process with one of our spoilboards and even use the dowel pins that come with our system. You can machine holes, in the same pattern like you would here, like 2 on one edge and 1 on another, and put a 90-degree corner up against that, and then run side 1, and then flip it over and put it up against those pins. And even if you want a profile on side 2 or side 1 or whatever, you just put it up against the pins, and once you're in position, you can remove them and then run your second side. So 3 pins, you can put holes in your part and then mating pins in your spoilboard and flip it onto the pins. I really like having on dedicated fixtures, I love having recessed pockets that have one reference corner and then the rest of the pocket's oversized to account for the part size. And when you flip it into the pocket and against the corner, and then have a gasket down there that sucks it down. So you basically, when you're programming, you can imagine you basically take the parts on side 1 and then flip them over into another side of the fixture for side 2. And the really cool thing with that is then you can be running a combined program where you have side 1 and side 2 as part of the same run, and it increases your efficiency because you're doing one flip, reloading side 1, and then keeping everything going, and longer run times, etc. So, yeah, 3 pins and holes, machine a fence into a fixture plate. We've seen people take pieces of acrylic and make holes in them that they put on their spoilboard, their tile gasket, that interfaces with the holes and the AirWeight, and they use long pins and put like a fence in there. That's been really cool. There's tons of creative ways to do two-sided ops. The key is that you just have a reliable reference to get to on side 2, whether that's you machine the profile on side 1 and then use that as your reference for side 2, or you make holes and then flip it onto pins. There's a variety of ways to get there, but in my experience previously, a lot of times I didn't have excess material to put locating holes in the stock. In other words, the material was so expensive that we would actually cut out everything on another CNC with an 1/8 inch bit to get the optimal yield out of the sheet. And then we had these individual blanks that then we would take and put onto a custom fixture and do side 1 and flip into side 2. So, if you can use the profile of your part, it's pretty nice because then you can put things kind of closer together. And you can waste less stock, but pins are also totally valid. Cecil, thanks for the question. For printing those hard stops, just email us info@airweights.com and we'll send you the file. I probably should we'll see if we can just host it on the website. And if that were the case, it'll be on our instructions page. But for now, like you're a standing customer, just email us and we'll make sure to send that to you. John, how to order more plugs. We are in the process of offering basically a replacement hardware kit that will essentially be everything that you came with your AirWeight as a little baggie that you can just buy and we would ship to you. If you're having issues with losing plugs, just send me an email. I can send you a link to where to buy them yourself if you want. You can buy them. You can buy those particular plugs on McMaster Car if you're looking for just a direct replacement, or if you email us, we can work something out. I'm happy to help you out with that. I know it can be a pain to find those little black things all over. Yeah. Okay. Brad Shelton NTX. How do you connect multiple vacuum tables? So kind of went over this already. We use a manifold for that. It's not the only way to do it. I should also say, all of our vacuum tables have inlets on all 4 edges. So one way you can connect them, but I don't really recommend, is you can run an airline into one edge and then take the plug out of one of the other edges and put another fitting on the other side, run an airline to the next one and sort of daisy chain them together. That's okay, but it doesn't provide the flexibility that you would get with a manifold. And the reason a manifold is nice is it gives you the opportunity to isolate vacuum to any one of your zones on your vacuum table, on your machine table. So like behind me, I have 4 individual 24 by 24 AirWeights installed on my system. And I have a manifold I have several manifolds because we energize our products as they're being produced, but that's beside the point. Anyway, we basically have the ability to shut off as many of the vacuum tables as we want. And what that does is it takes all of the vacuum flow that you would be using to apply to your entire setup, and you can isolate it to one table. And the advantage of that is if you have really, really small, intricate parts, you can isolate basically the capacity, the amount of holding force to just one zone, and really get after trying to achieve good work holding on a very small part. So a manifold is basically just an air distribution block. You take, the intake from your pump, connect it to the manifold, and from the manifold, you run lines to each individual vacuum table. Next question. Larry, which vacuum pump am I using? I'm using the 17 here, and that is a little bit of a catch. So I'm using the biggest, baddest thing that we offer. And for example, if I was to run a 5 CFM pump on that bare spoilboard right there, the part would slide around most likely a lot more than it would with the 17. But using a gasket is still totally valid with a 5 CFM. And even if you put a big part on that bare spoilboard with a 5 CFM pump, you still get adequate work holding if the part's of big enough area. So I'm using the 17 in this case, and I can't say enough good things about this 17 CFM pump. The only caveat with it is it's a big system, and we've been able to offer it at 110, an input voltage of 110. And that means it takes a lot of inertia to get all 4 cylinders started and moving. So if I turn on the vacuum pump, it gets to deep vacuum and everything's really well sealed, and I shut off the pump and I go to turn it back on, there's no air that's passing through the system, allowing the cylinders to turn and start to fire up. So sometimes you have to equalize pressure and allow it to fire up and get overcome all the inertia and get it moving in order for it to kick over. And then once it's running, it's just, it's amazing. And we do have some limited quantity of 220 volt pumps available right now, but those are mostly for EU customers, just FYI. Are there instructions for assembling the 17 CFM pump? I don't see it on your site. Been busy at work and family getting to it. Yeah, all good, Lawrence. We're working on a assembly video for that right now. It's one of those products that we just really wanted to get out to customers. But at a really really basic level, essentially the pump sits horizontal compared to our 5 and 9 CFM, which sit with the cylinder heads vertical. And what that means is that, to walk you through the assembly really quick, on the bottom side, there's 4 exhaust mufflers that need to be installed. And then on the side of the pump, there's an intake. and we provide an elbow, a male, a filter, and a push to connect that all get taped, and then, Teflon taped and then screwed together. And the tape is mostly just so that you can clock the threads at a position that's desirable for you, without having any leaks. So that's how that's done. And then, from there you connect your air line, and it runs to either your manifold or your vacuum table. So the instructions are forthcoming. I know that we're a little bit late on that, but we just wanted to get them out. And if you have specific questions, feel free to reach out to us for support. What is the maximum time the pump should run? Thank you, Cheryl. All of our pumps are continuous duty when they're pulling deep vacuum. So if you're for example, we run our products to produce our products, and we run them all day, every day, and they don't stop. They are just 8 hours going. And so we're kind of our own test case or user example, in that we're leveraging our own products to make more of them. And we have had, over the course of our existence as a business, I've had one pump fail on me, which was a toggle switch. It was never the pump mechanism. But the short story is they're rated for continuous duty operation. And that's pretty different than what you see in other vacuum solutions. We're targeting a solution that you can run day in and day out and produce product with. So continuous duty, there is some maintenance required. You should empty the intake filter. There is a way to rebuild the cylinders, but I doubt anybody using it for a hobby would ever get there. If you're using it for a business, reach out to us if you ever have an issue, but we've seen nothing to date. And all pumps come with a 1-year warranty, so you're covered for at least a year. All right, Harry, what's the best way to avoid going through the fixture plate? That's accurately setting your Z depth. So the fixture plate is 1/4 of an inch thick, and you don't need to cut through very far unless you have, for example, a ball nose bit or something that has tip geometry that you need to get past in order to get a clean profile cut. We have provided thicker fixture plates to customers in the past, so if that's something you're interested in, please reach out and let us know. But the general answer is, if you're using a standard, flat tool, like I was using just here, you just want to dial in your Z height so that you know exactly how far you're cutting through by, and that comes down to measuring your stock. If you're setting the Z height from the top down, like your Z zeros at the top of your material, or making sure that you set the Z0. Some softwares don't have this capability, but many do. You can set Z0 at the top of the fixture plate, so in your code if all your values are positive, or if you're only going down minus 20 thou into the fixture, you're never going to cut all the way through. So it just comes down to understanding your programming and also your setup and how you're setting your zero on your machine. Jen, so if you're using MDF or a fixture plate, I assume you're removing all the plugs from the base plate. Is that correct? Yes, that is totally correct. So when you're using any one of those surfaces, they cover the entire surface of the vacuum table. And on the bottom side, underneath there, you don't need any plugs in there. All you need to do is just remove all the plugs. And again, don't forget the corner touch plate feature that you can just pull that plug out too, and then set it onto the entire vacuum table. In fact, that's a way that we QC our products before they leave the building. Every single AirWeight is leak checked on site with a pretty strict leak parameter. And we encourage people that when they set up their system to also run a leak check using the plugs. But we leak check with a perimeter gasket to seat the seal, make sure it's well compressed and adhered, and you don't need any plugs in there. In fact, it'll interfere unless you cut them flush. So no plugs. Have you done any testing to see what the lateral force is needed to break the material free from the table? I would say qualitative, but not quantitative to the point of failure. That's something we can consider. There's a little bit of a safety issue with that, but something I'm curious about. I mean, it's something that you can calculate pretty easily, and we can essentially, in any of the testing that we've done to date, we max out the force gauge usually. So, you know, again, I'm not sure if you were here before, but doing the testing on the table, the whole entire machine will shake before I can get the part free in many cases, and especially with larger parts, you know, that's even bigger. But all it comes down to is quantifying the coefficient of static friction between the workpiece and whatever's underneath it. Once you know that, you can pretty readily calculate how much lateral force it takes to shift the part. But empirical data is always better, so I'm a fan. I think it's probably worthwhile. JR, can you demonstrate a very aggressive cut, greater than 500 inches a minute, greater than 0.75 DOC, to demo the lateral force with some hardwood/aluminum? I think that's going to have to wait for the next live stream, JR. But it's not the first time we've had the request. It's something that I think I have no doubt that the product will perform in that case. And again, it just comes down to the area and the work holding method. But I mean, I can rip through the stuff that we cut, you know, the plastic materials we cut at full depth, 200 inches a minute, 300 inches a minute. I don't think that we're going to be limited by the work holding, but it would be a really fun test. So I appreciate the suggestion. Doug Stevens, would putting the tile gasket on both sides of the spoil board increase effectiveness? Interesting suggestion. I haven't tested it myself. My concern with that would be you need to provide a clean surface for the seal in the vacuum table to interface with the MDF. You're also limiting the flow rate through the bottom surface, and I could see that working with a less dense material than the stuff that we use, potentially. But it could be worth a shot. I think you would probably have a slightly reduced holding force using our MDF spoil board. Can't speak for another density just yet. Recommendations on cutting large sheets of UHMW, let's say 2 by 2 by 0.25, dealing with potentially bowed material and required cut-through holes. Good question. So if your sheet is bowed, something like an MDF spoil board or tile gasket isn't going to produce the depth of vacuum that you need to collapse the material. So I would highly recommend using either one of our pre-cut fixture plates or buying a fixture plate and making it yourself. To account for anywhere that you're going to cut through, you know, mark those locations, put a gasket around it, and then the border of your part also. And that's going to allow you to, I mean, you have so much area to work with. I mean, we're talking thousands of pounds of downforce. The thing is not going to move. The key is just you have to account for the areas where you are going to cut through so you don't breach the seal and you maintain that really deep level of vacuum. Skip, is 1/4 inch MDF from big box stores porous enough? It's a mixed bag, because what I've learned is that MDF is sourced regionally for big box stores, which means that the MDF that I go down the street and buy could be very different from the 1/4 inch MDF that you go down the street and buy. And so I can't recommend buying MDF for vacuum tables from big box stores at all, unless you can with certainty determine the source and the tolerance on the density in order to get something that you know is good. Highly recommend going to a local lumber yard, someone that has a material that they understand and that they can give you a spec sheet for, so that you know what you're getting, because the big box store is just a mixed bag. Mike, what option would you use if you wanted your AirWeights example to be a complete profile cut through? It is. It's a complete profile cut through. And with a part of this size, pretty much any of the methods would work. So, you know, obviously not the direct mount method if you want a complete profile cut that's all the way through your part. But something that is worth noting about that is you can dial in your onion skin to be pretty darn thin. So that's something to consider. But if you were doing this example part, if I was doing this example part and I'm making it in production, I'm definitely going to be setting up a fixture plate. I think tile, gasket, and MDF would work for something of this size, especially if you had a nice flat material. And probably one of those two, I'd lean towards fixture plate, but I lean towards fixture plate for everything. So, JR, have you ever attempted engraving glass on an AirWeights table? I have not, but I do think that glass is a great candidate material for our system because it is so flat, so non-porous, so smooth. I think it would work fantastic as long as you have enough area on your part. Edwin, oh man, Edwin had a great email exchange with you, and yeah, looking forward to getting you up and running the best we possibly can. What's the best way to find air leaks? Vacuum leaks are, there's a lot of different ways out there, ranging from unbelievably expensive all the way to very affordable. I tend to lean for the stuff that we're doing towards the very affordable side of things. One of the easiest ways is smoke. So there's these little kits that you can buy where you create smoke that's, you know, non-toxic and not an issue. And then you can take that smoke and walk around all of your fittings and put it all around the edges of your parts and things like that, and start to see visibly if air is moving into a particular area. And that would be an indicator of a leak. Another way to do that is with a stethoscope. So this is kind of hard because you're making noise while you're trying to do the leak detection. But a stethoscope can amplify the sound enough that you can go around and find this hissing noise that you know is correlated with a leak in that area. So those are two kind of readily accessible ways. There's very sophisticated instrumentation, helium leak detection, all sorts of things for doing leak testing. You can also just do a simple pressure decay test. When you basically put the whole system under vacuum and then turn off the pump and watch the gauge, and the slower the drop, the more sealed you are. So, typically our systems here, when they're leak tested, we see like, less than 2 inches of mercury lost over 10 seconds, which for a vacuum table of this size is a pretty good amount. That's a pretty tight system. So if you're in that range, I would say you're pretty good. But if you want to do more significant leak testing, smoke or a stethoscope. Guy, would you recommend a 24x48 table or two 24x24 tables with a manifold? Great question. And this is kind of a customer preference. So I really like running 24x24 tables because then I can fabricate my 24x24s and my 24x48s and cut completely through, and there's no dramas, and it's all really easy. But that's specific to my experience, my use case and my application. So the general way that I like to approach this is to look at what are the biggest parts you make and what are the smallest parts you make, and to sort of get an idea of where you spend the most time making, what's the size. And the vacuum table should accommodate the majority of your work. So let's say your work pieces are generally smaller than 24x24. I would go with two 24x24 tables to give you the flexibility to be able to shut off one with the manifold and isolate flow to just one table. On the flip side, let's say you're cutting, quarter sheets of plywood all day long, and you want to have a really nice, flat uniform surface with no gaps in the vacuum table. A 24x48 is way more applicable because you're processing sheet goods. You don't want to lose work holding at the seam, and you want to have, the ability to run at rate and have consistent work holding over the entire area. So it's really application specific, and I tend to lean towards individual tables, more modular for people who are making piece parts. And I tend to lean towards larger tables for people who are processing sheet goods, making larger components. So that's kind of the recommendation there. Kamani, you do a lot of surfacing. Do you have a bit you prefer to use for the boards? Good question. We have some bits that we're testing right now from IDC Woodcraft. They make a four blade brazed surfacing bit in 1 inch diameter and 1.5 inch diameter. Those are pretty nice. We use these cheap insert blades from Amazon. So they have a little, rotatable insert knife, and they work really well. It's nice because you can rotate the blade and get more and more cuts out of it. But there, you could go, you can get super expensive surfacing bits that cost a ton. And if you're doing a lot of flab slattening or things like that, those are great. We like to keep the cost of our tooling down as much as possible and have higher quality cuts that we're changing out more frequently to keep the product quality really high. So it's just different schools of thought. We use a 1.5 inch diameter for our stuff, and we'll probably be switching over to a 1 inch diameter to accommodate some of the upgrades we're making to our machines. So yeah, not a particularly recommended one, but I know the one from IDC does pretty well. Jen, on the website, I only saw rolls of adhesive gasket strips. Do you have rolls of non-adhesive gasket as well? Maybe I just missed it. Great question. I had some right here somewhere. We do sell it. It comes with every vacuum table. We call it grid gasket. And the picture is a little bit hard to tell because in the photo, it's installed in the vacuum table. But if you go to the search bar at the top of our website and just type in grid gasket, you'll see it there. And it's not adhesive, and you can buy extra lengths of it. We sell it in 25-foot lengths and in 50-foot lengths. The 25-foot ships with every single 16 by 16 unit. It ships with every single 24 by 24 unit, and it ships with every individual slat that is for the Onefinity series QCW vacuum slat stuff. And then the 50-foot ships with our 24 by 48 system, and those are both available for purchase as accessories. Again, these are all All-Star CNC products. Next question. Do you have a Canadian distributor for your products to purchase fixture plates and other supplies? Not yet, but we are working on it. And I know that you need that, Jen, and we are working on it. Lee, what do you use as a sealer? So I'm assuming you're talking about for MDF. There's a variety of materials that work. Very common is just wood glue. So you can use wood glue and just go around the edge and that border on the bottom side. People use shellac, sanding sealer, epoxy, I mean, you name it. Epoxy actually works really well if you can heat it and get it to like seep into the layer of the wood. I've seen some people do some pretty cool stuff with that. But yeah, generally just wood glue or any sort of sealing glue, bonder, anything. It's just something that's going to make it non-porous right at the surface. Could you post the specs I should be looking for when sourcing MDF? Yes, they are on our instructions page under the tile gasket and MDF section. So that's there. Again, 48 pounds per cubic foot is the density you're looking for. And I would love it if you would source your own. It would really help us out. Any other questions?
It looks like we've answered all of the questions.
Right on.
So we will be hosting a giveaway. In order to enter the giveaway, you just have to write #spring into the chat bar, and we will start collecting entries. Jace, do you want to tell them about what we're giving away?
Yeah, so the giveaway today is for a 24 by 24 complete system. That includes the 24 by 24 AirWeights table, which is one of these tables that you saw behind me. It'll include all of the hardware that you need to install. So the locating pins to position it on your spoil board repeatedly and accurately and square. The mounting screws to secure it to the spoil board. All of the little black plugs that you put into the ports when you're using it with direct mount. 25 feet of a non-adhesive gasket, or the grid gasket material, airline, pump, intake filter, all the fittings you need, the exhaust muffler mounting feet. It's a complete system that's just less accessories. And it's a really out of the box solution that you can take and mount onto a machine and be cutting relatively quickly. So that's what we're offering today. And yeah, I hope good luck to everyone on this entry. I think it's a pretty full featured giveaway, and I hope somebody really gets it that needs it. Yeah, Sting. Ron. Yeah, so we're just going to give a little bit of time for everybody to enter that's here. We'll give it a few minutes and make sure everyone gets a chance at this. We're not going to probably have, I don't know how many people are here, but I think there's a pretty good shot of winning this system. Odds are pretty good. And of course, as part of that, you probably get to talk to me and get some help and support with whatever you need. So yeah, I hope it's complementary to some system that's existing. There's a lot of people here that have systems, which is great. It's exactly what we wanted, to help educate and keep teaching the best way to use our systems and helping everybody get to a place where they're really using their machine to its full potential and having fun doing it. So yeah, looking forward to supporting whoever wins. The other thing I'm going to mention right now is that we actually have a sale running at the moment. So we're going to continue. We're going to extend the sale. We extended it for the live stream, and we're going to let it go all the way through tomorrow at midnight Pacific. So if you're interested in purchasing something based on the information shared here, use discount code SPRING15 at checkout, and you'll get 15% off your order. The discount code's going across the bottom of the screen right now, and give you a little bit of savings. And just a thank you to our community for continuing to support and helping us out, getting these systems out to the people that need them. So yeah, we'll do a couple more minutes on the giveaway. And I think if there's any other lingering questions that people have, I'm happy to answer them. I think for the most part, we touched on a lot of stuff. I see your question coming through, guys, so I'll tackle that. I'm curious about your answer to Jen's question regarding Canada. Are you hoping to set up a distributor in Canada for the complete systems? And Guy, yes, that is the intention. It's a little bit tricky. Currently we're selling in Canada, but our customers up there end up biting the bullet. And in Jen's case, it's just not fair. And we can't stand behind that as a business, customers having to pay so much money for import and fees and everything. So our intention is to get, a distributor that will be able to sell the system directly at, market value and not have to pass off so much expense to the customer. Yeah, thanks for all the feedback, you guys. Really appreciate it. And I think we'll review kind of all this info and help make some more content from this that'll be informative. But I'd love to do these more. And if you guys are interested in seeing that again, or seeing an evolution of this and more examples, more cuts. I mean, I know JR wants to see me cut, 3/4 inch depth of cut on maple at 500 inches a minute or something. But yeah, I might need like a 12 horsepower spindle for that one. So we'll see. Well, it would be fun to do some more of these if you guys are interested. So what do you think, Kate? Any more trickling in?
Shall I press draw?
40 entries. You guys are going to be stoked. Someone's about to win. Yeah, I think if there's no last call for any entries, I think probably everyone's in by now. At 7:24, we're going to run the drawing. Good suggestion, Joe. We can talk about doing a demo of the slats. We need to do a whole kind of video series on those because it is a unique setup with the integration of T-Track. There's a lot of creative things you can do. And it's a great example of having a manifold and a large source and isolating flow and things like that. So yeah, and also the installation and setup is, climbing under a machine and doing all that. It's not super easy. So I mean, it's relatively easy, but just takes a little time. So that's a good suggestion. All right, we got one more in, Zach. 2 more in. All right.
All right.
Let's send it. Mike, no way. That's awesome. All right, Mike. Well, we'll be adding to your arsenal. You can just send us an email, info@airweights.com. I think you have our contact already, if I'm not mistaken. And we are excited to be supporting you some more. And depending on your needs, we can work with you on getting you the best option for your setup. So like I said, just send us an email, info@airweights, and just put in the title live stream winner 4-1, and we'll get you taken care of. So thanks so much. And I think that's probably going to wrap it up for today. So a lot of content in there, a lot to cover. And this is our first one of these that we've ever done. So grateful for all of you that showed up and supported. If you're interested in getting something, don't forget to use discount code SPRING15 until tomorrow night at midnight Pacific. So as long as we could probably give you in a day. And yeah, thanks so much for being here. We really appreciate you all. And we'll see you next time. Thanks so much and have a great evening.